So if you are not in class today, first off, we miss you. But our homework today is going to be 4-6. This is going to be due on Tuesday. We're going to talk about this problem here with Rubber Ducky here in a moment. But I first want to introduce these books to you. So, Elena, can you hit the power button over there? It's right beside that yellow Post-it. It's the big black button. Thank you very much. It'll take a second to turn on. There we go.
Hi, I'm Danica McKellar. Welcome to the Math Doesn't Suck channel on My Math Universe. Okay, so I've been acting since I was 12 years old on shows like The Wonder Years, and I still act today. I've done episodes of How I Met Your Mother and The Big Bang Theory, and I'm the voice of Miss Martian on a cartoon called Young Justice. And I also write math books.
Math books!
Yeah, math books. Believe it or not, I used to hate math. I was terrified of it. But then I finally figured out how to make math easier and not such a big deal. And then I felt smarter, I had more confidence, I was a better student and a happier person. And that's why I started writing math books, because I want you to feel the same way. My first book is called Math Doesn't Suck. There are a lot of things that do suck. I'm sure you can name plenty of them. Finding out your best friend lied behind your back? Sucks. Getting acne? Sucks. Parents getting divorced? Totally sucks. Been there. But math doesn't have to suck. Do you like money? Most people do. Math is the language of money, and being smart in math will keep you from getting ripped off, it'll help you with planning and budgeting for parties and vacations, and prepares you for better paying jobs. And if you ever want to start your own business, guess what keeps the doors open? Math. But the best thing about math is that doing math makes you smarter and gives you that confidence that comes from feeling strong and capable, and that makes all of life better. What a lot of people don't realize is that being smart in math isn't something you're either born with or you're not. You're never stuck at one level of math smartness. The more math you do, the stronger your brain gets. It's like going to the gym for your brain. And every time you do a math problem that you thought you couldn't do and then you figure it out, you've just shown yourself that you're stronger and more capable than you thought. And that builds confidence from the inside out. Suddenly you're like, yeah, I can do math. And anything else that people think is hard, bring it on. That kind of inner confidence changes the way you walk into a room, it gives you a better smile, and it makes you feel great. You know, a lot of people think math is for other people, not them. And we've all heard the same stereotypes. That math is too hard, too boring, only for guys, only for nerds with glasses and pocket protectors, or that it's only for old men who look like Einstein.
So who's heard any of those stereotypes? Girls aren't good at math. I can't do math because I'm just not smart. Only nerds do math. Only old men with, like, crazy hair do. Yeah, these are stereotypes, and they are wrong.
Or that if you're pretty, you can't be good at math. And that you don't need math because you're certainly never going to be a scientist. But math is for everyone. It's for you. And it'll make your life better, no matter what career you choose. So I'm going to help you out here and make math a little more pleasant. I have videos to help you out with homework and tests, and also some confidence-building, brain-strengthening math problems you can download. Some teachers might even give you extra credit if you do them, so be sure to ask. Thanks for visiting the Math Doesn't Suck channel. Practice some problems, watch my videos, and find out more about my books at danicamckellar.com. I'm really excited to share all the tricks I've learned to help you kick some serious butt in both math class and life.
She was somebody's girlfriend. I think she was the chick with the yellow umbrella.
She was on Impractical Jokers for an episode.
Yeah, she's fairly famous because she was on the Wonder Years. But so if you search Danica McKellar, she's got different like playlists or different channels. So she's got one that the Math Doesn't Suck channel has like 11 videos. There's an interview of hers there. Math Bites are all just little like videos explaining things. And we'll watch her pie episode when it comes to Pie Day. But we've got 4 books from Danica that we got in the library per my request because I love her writing style. She's funny, she's smart, and she's a girl. And a lot of times girls get this attitude of like, well, I'm a girl, I'm not as good as the boys. Screw that. Girls are just as good as boys, and a lot of times you guys are better than us. So, we have the first book that she just talked about, Math Doesn't Suck. And the next book that she made, kind of a play on words, Kiss My Math, is just So if you leaf through these, it's got like writings, but it's got fun problems to solve. It's got examples showing out. It's got real world application type problems. And guys, you independent read every day. If you're tired of like, you know, the Hunger Games, or you're tired of crap, now I can't even think of it, the vampire books, or any of the other any of the other cliche middle school stuff, this will not only engage your brain in reading, but it'll engage your brain mathematically and make you smarter. So there's those 2 books. Then these dance on the line of middle school versus high school. So these are a little bit higher level, but I would encourage you guys to still go for it. Hot X, all about algebra, because X we use as a variable, but also she makes jokes about like an ex-boyfriend. And then Girls Get Curves, all about geometry. These are not just for girls, but because most often girls need the extra encouragement, that's why she wrote them somewhat targeted towards girls. But boys, you can read these too. They're fun. She's a great writer. And she shows that you can be very multi-talented. She was a child actress. She became famous before she ever graduated high school. She could have never cared about getting better at math. But she's smart and realized that math is very important to a successful life, especially people with lots of money. The dumbest thing you could ever do is become rich and not understand math. Because then you will get ripped off, people will take advantage of you, and before you know it, you're broke like MC Hammer. MC Hammer now had to claim bankruptcy because he had no idea how to handle all his money. So MC Hammer, like the guy, It's Hammer Time, yeah, he was famous, made tons of money, now it's all gone. Didn't know how to manage his money. Yeah. So, all that to say, I have these books. You can check them out, but I'm going to have them because I'm going to try to connect people with them. So, you would just get it from me and then walk to the library and sign it out like you do with the normal books. Jeremiah?
How come she was an actress and she was on 2 shows and now she's making actors?
So she's still on show. Like, I saw her randomly in a movie that was on the Lifetime channel this summer. Like,
a lot of movies on Hallmark.
yeah, or maybe it was Hallmark. But yeah, so she's still an actress, but she didn't just want to be an actress. She realized that girls, especially middle school, early high school girls, like, they start to get this idea of like, oh, I'm a girl and I can't be good at math. And that got her like really kind of mad. And like her interviews are kind of interesting about why she wrote these books. But she like decided somebody needed to reach out to these like young people, especially girls, and tell you like, math doesn't suck. You are not stuck at one level of knowledge. You can do this. You can get better. Anybody has that ability. That was her big push. And she just felt a calling that she had money from being an actress. She decided to publish some books. And luckily the books like are good books, so they became great sellers. She had enough money. She could have published the books and they could have been a flop and whatever. But they were well-written books. Like, try it out. Give it a shot. Read a chapter. If you don't like it, you're not going to hurt my feelings. But give it a shot. They're brand new. Like, we just got them in this year, so nobody else has read these yet. Now, we have Rubber Ducky. Rubber Ducky, and by the way, this pond, when we run or when I go ride my bike, I like to go around this pond and quack at the geese and the ducks. And yes, I actually do quack at geese and ducks. I'm kind of weird. It's okay. So, Rubber Ducky wants to go from... And I especially wrote this because of Monica and my argument yesterday. Rubber Ducky wants to go from his pond to Phoenix. This is real Google Maps. These are real distances. I took the time to actually plot out all the distances and everything. So, Rubber Ducky wants to know how far he has to travel. Because, well, he's a rubber duck. He can't really travel that far that quickly. So, we got to help Rubber Ducky figure out what in total will be the distance that he travels. Now, my hint up here is that the easiest way to do this, the quickest way, would not be to take this distance, then that distance, then that distance. I could just take all of the horizontal distance, and then the vertical distance, and then I can just sum those together. So if we want to figure out all of the horizontal distance, how can I figure out the total distance between 2 points regardless of their values, positive or negative? Because remember, negative values are directional. If this was where I was standing, north, west, east, south, north would be positive, south would be negative, west would be negative, east would be positive, but they don't really, like, that's just to name based off where you are. That doesn't mean anything about how far you travel. So, like, to get from a point of negative 7/10 to our point of 0. So to go from here to here, how far of a distance would that be to cover?
0.45 something miles.
Ah, but that's the y value. So here's the x value, negative 7/10. And if this is the y-axis, what's your x value at the y-axis? 0, right? So your y value, or sorry, your x value on the y-axis, we could label this y-axis if we want. This x value is 0 because that's my origin point. How far is it from a negative 7/10 to a 0? 7/10, right? That's easy to think about. But if I took this and I said negative 7/10 minus 0, and I did the difference between them, my answer would be negative 7/10, which is why we touched on this really quickly yesterday. All distance problems are set up. So I want you guys, and I'll give you your notes in just a second. You'll write this. Well, I might as well give them out now.
Did you already give us notes?
Did I? Well, nobody has them out, so that's why I thought. Whitney has them out.
Me and Dominic have them out.
Nice. Guys, if we don't finish notes, you know that's the first thing we're going to do when you come back to class.
I have them out.
I think Ozzy was like, how can I make more noise? All right, distance. And actually, you should have this in your notes. This still won't open. Something's wrong with...
You broke the smartboard.
Well, it's not the smartboard. It's that my PDF won't open.
You broke it.
I broke the bush
It had a light What? It made it work too hard. It has a motion to break it.
Sweet. All right, we're open now. We talked about the cumulonimbus. We talked about the whale, right? So this, awesome, is exactly what I was just about to get us to. The distance between any 2 points is the absolute value of their difference. It doesn't matter what order you subtract them in, which is the awesome part. I can do A minus B, or I can do B minus A. Decide which order you put them in by which is easiest. Guys, I want to make your life easier. So this lets us choose the easy option. If I look here at the distance for the entire x distance. So we just said that if we wanted to figure out just this, that would have been 0.7 because we went from a negative 7/10 to a 0. But if I want to figure out the whole horizontal distance, I'm going from a negative 7/10 to a positive 8/10. So my horizontal, yeah, it's 8/10. My horizontal distance, HORZ is a way that you can abbreviate horizontal. Is it easier to do negative minus positive or positive minus a negative? Ozzy?
Positive minus negative.
Why?
Because the bigger number goes first. Well, not that, but...
That's not why. I mean, I can agree with your thinking, but that's not actually why it's easier. Tom?
It's basically just regular subtraction.
No. Because if we go positive minus a negative, now that I write it out, I think it might be easier to see. You see your mistake?
Yeah.
Evie?
It's because you have to do that thing where you make the little thing, and then you have to make your negative into a positive.
If I subtract the negative, all I actually have to do is add them. And addition is easier.
Yep.
We want to make our life easier. So now I can do 0.8 plus, 8/10 plus 7/10. What's 8 plus 7? 15, right? So I get 15/10.
Yep.
That'd be 1 and 5. Yeah, that's... It's 1.5.
Now, what is this number?
1 and
I can't see it.
It's 15
100.
hundredths. Now, what I said about 15/10 is right. It's 15/10. But when I write that as a decimal, I can't write 15 in the tenths place. I can only have individual digits in the tenths place. So it's really 1.5 or 1.5. So my total horizontal distance is 1.5.
I didn't get it.
What do you mean you didn't get it? Like, you have a question or what?
Yeah, I didn't get how you got 1.5.
So I'd start with my positive value.
I got how you did the negative with the positive thing.
Okay, so if I have 8/10, think about making this a fraction. I have 8/10, and I'm going to add to it 7/10, because you're okay with how we got to addition. What's 8 plus 7?
15.
So I get 15/10. But how many times can 10 go into 15?
Oh.
1.5 times. With me now? Cool. Thank you for asking. Never let me move on if you don't understand something. Our vertical distance. Yeah.
Last time, didn't you say if you did a negative minus a negative, it would just one?
I didn't do a negative minus a negative, though. I did a positive minus a negative. So, on our notes from 4445, we had written down that minus a negative. All that means is minus a negative value, but there has to be a number out here. It doesn't matter whether this number is positive or negative. What we care about is these being right beside each other. Doesn't matter what this number is, and this, like, as long as it's minus a negative, I can make that addition. So make sure that we go back and check those notes if things don't totally make sense. For the vertical change, again, if I do positive minus negative, it's easier because it becomes addition. So my positive value, 45/100ths, minus the negative 25/100ths. That then becomes addition. So what's 45 plus 25? Huh? So this, I can leave that in the hundredths place, but it actually just becomes 70/100ths or 7/10. So then if we want to talk about the total distance traveled, I can just take my horizontal and my vertical. So I have 1 5/10 plus 7/10. It's going to come out to be
2 tenths.
So it's either 2 2/10 or 2 20/100ths. But we don't need to say 20/100ths because it's kind of like that 0 doesn't matter. So if we stacked those and did the addition, you'd see this. But guys, this is real distance. And this is actually when I ride to school. That's about how far I go.
Oh, you ride to school?
Not when my backpack's heavy, I don't like to because that's more dangerous. But I'll come here like on the weekends and stuff. If I don't have to bring my laptop, I'll ride my bike. But like I have been recently, if I need to go to Kroger, like I just ride to Kroger. My wife and I bought new bikes with our tax refund this past year, so I have like a nice bike now. I grew up biking everywhere. So I will incorporate riding bikes into different problems through the year. If you ever need help with fixing a bike or anything too, I'm your man. I know how to pretty much do anything on a bike. Jeremiah? The notes from yesterday? So, all of these up over here, extras. I used to ride BMX. I never got too crazy because I liked my, limbs and things to be attached and not broken.
What was it like riding everywhere? Like, these days it's too dangerous.
In Coshocton, it's a very small town, all 25-mile-an-hour speed limits. It's a little different there than what you guys grew up with. So Rubber Ducky would have to go a total of 2.2 miles to go from his pond to Phoenix. That's on Billingsley. This road right here is Billingsley. So if you reference Hard Road's up here. It's north of that. Here's our learning target. We can determine the distance between any 2 points by using the absolute value. And this because it has to be a positive value. Distance cannot be negative. It is impossible. So when we look at P, Q, Q, R, and R, S, we want to figure out the distance between P and Q. Oh, crap. They're both negative. So with Rubber Ducky, I was lucky that I had... Rubber Ducky, I was lucky. That one was positive and one was negative. But if they're both negative, do I want to set up absolute value of -5 minus -2? Or do I want to set up... I'm just going to put it up here. -2 minus -5. Which one of these would be simpler to deal with? Honestly.
Okay, this is just the absolute value question.
Okay.
Do you answer it
value the separate number, then add it?
You absolute value the answer. So remember with PEMDAS, with your order of operations, you have to solve inside the parentheses first. Absolute value works just like that. You solve it, then make it positive.
Oh.
Jeremiah?
It's not really which one's easier. It's based on your opinion. Like, if you think that the first one's easier, then the first one's easier for you.
I love it. Which of these is easier is totally a you question. It's not a me question. Now, I will tell you, though, when I turn these into addition, this now becomes -2 plus 5, whereas this becomes -5 plus 2. It depends on how you like working with the numbers. Would you rather have a bigger negative and come up positive, or have a smaller negative and come like across 0 into the positives? This gives me an answer of +3, and then when I take the absolute value, I get 3. This gives me an answer of -3, and when I take the absolute value, I get 3. So either way, we're going to get the same answer for the distance between P and Q. So I want you guys take a moment and try to solve distance between Q and R, and distance between R and S. While it's capturing, it like disappears for a second. So since we don't need P anymore, I'm going to go ahead and move over so I've got some space. Now there is an easier option for QR. Dom, are you trying to tell me which option's easier? Okay. Which option up there would be easier?
3 minus -2.
Why?
Because the -2 would become a +2.
Well, the minus and the negative. I agree with you, but these join to make a positive. So this really becomes 3 plus 2, and I'm actually going to switch back to blue so I don't confuse people. This becomes 3 plus 2, and I don't even need the absolute value anymore because what's 3 plus 2? 5, and it's already positive. Now, when I look at the distance between R and S, there's still an easier option. Even though they're both positive, which of these is easier, my first or my second? Katia? The second? Why?
Because you have your bigger number.
Yeah, I have my bigger value first. That subtraction's easier. You get 2. And that's our answer. Any questions? So this would have given me absolute value of -2, would still give me 2. This would have given me absolute value of -5. If you're at -2 and you go down 3 more, still that's 5. Any questions? Preguntas? Preguntas means questions in Spanish.
Yeah.
And it's a fun word to say because you can roll the R.
Yeah, it is.
So, and I put this on the back as another reminder, so when you're on the back of your notes, you can look at it again for another reminder. It doesn't matter which order you subtract them. Oh yeah, if you didn't, I forgot about this because it's been so long since I taught this. If you didn't have space out here to do your work, you can show more work here if you want to. So, but now, without the number line, we need to solve these 3 distances. And I'm going to give you guys like probably 2 or 3 minutes to do this. I want to see if we can accurately solve all 3 of these distances. Yep, go ahead and do it. Yep.
The bus question.
What's up? Good. I would prefer that you do, because as the problems get harder, that will become more important. These notes are for your reference. Yeah, you can always move ahead. You can always work ahead. Alright, since I feel like some people are getting done. If I show the workout for this, and I know some of you are choosing not to make this the easiest, how should I do my work? What order should I do this in? For the first one, if I want to make this easy, hold on.
Oh, sorry.
No, Jeremiah. Yeah? Yeah, Jeremiah. Woohoo! It just took me a second to get it out of my brain. Jeremiah, what's the easy order to do this in?
That first one?
Yeah.
I just subtracted.
Well, which -1 minus 5 or 5 minus -1?
I did the opposite. I added 5 plus 1 because you need to add them both together because you want negative, and then you have to go to plus, which means you cross the negative, cross 0, which means you have to add.
I'm so glad you said that. Jeremiah is applying a nice, easy rule about math that we could write out a whole proof and explain why this works. But think about, if you're trying to find the distance between a positive and a negative. Let's say my camera is the 0. And this will be weird for whoever's watching the video. Let's say my camera is a 0. This direction's positive, and behind it is a negative. So let's say, can I borrow you, Julian? Yeah. Let's say Julian, do you want to be positive or negative?
I want to be
Positive? Alright, so Julian is out here. How positive do you want to be?
8.
Very. So Julian is positive, let's say 77. Positive 77. He's really positive. And I am a negative 13. For us to span, let's say Jeremiah, just because he's standing. Jeremiah wants to walk from me to Julian. What is Jeremiah going to have to go past? 0, right? There's no way that he can go from a negative to a positive without a 0. So Jeremiah starts walking from I'm negative, right? So negative 13, he walks, now stop right there. How far did Jeremiah go to get to 0? 13. Jeremiah, go to Julian. How far did he go to get to Julian once he gets there? 77. So we know that he has to cover the whole distance from the negative, and then he's got to cover the whole distance to the positive. So since I know that both of those distances get covered, you can just treat both of the numbers like positives and just add them together. Because I know I have to cover the distance from the negative to the 0 and the distance from the 0 to the positive. Thank you, gentlemen. So what Jeremiah said was, I know that this is -1 to 0 takes 1, and 0 to 5 takes 5, so 1 and 5 together is 6. If I wrote out the work, I would choose 5 minus -1, because then this becomes 5 plus 1, and then that becomes 6. I know, because that's why I make my ones like this, especially now that we use absolute value. I would encourage you to make your ones not look like the absolute value bar. Or the way to differentiate that is make your absolute value bars either really dark or really tall. Honestly?
Okay, this is just clarification, but
Okay.
as long as you cover the distance, you just need to add it. Like across from 0.
Yeah, as long as they have opposite signs. Now, if they have the same signs, I can't look at this and say 5 plus 1 equals 6, because they're in the same portion of the number line.
So as long as they have different signs, and they both get covered, you just need to add them.
Yeah, essentially. So, between -5 and 1, though, so if I'm at -5, and I need to go to 1, do I pass 0? Or, sorry, -1. If I'm at -5 and I need to go to -1, do I pass 0? No. So since I don't, instead of adding those values together, I just find the difference between them, which, difference is distance, and I can treat them both like they're positive. Since they're both negative, treat them like they're both positive. Distance between 5 and 1? 4. Now, I could show out all the work, I could say -5 minus a -1, and then that becomes addition, and I have -5 plus 1, and then, sorry, that's all absolute value. That becomes a -4 in the absolute value, and that becomes a +4. And because my ones are not made specifically, it looks kind of messy. And 5 and 1, they have the same sign, so we can just subtract and we get 4. Any questions on this? Once, twice? No, what's your question?
I figured it out.
Okay, so yeah, that happens too. You raise your hand to ask a question and you figure it out. So to represent this, if I asked you to use an absolute value expression, which of these would work? Well, I either need -2 minus the 4 or the 4 minus the -2, and they have to be in the absolute value. So which of these would work? Does 1 work?
Well, the fourth one works. Well,
Andrew, right, by the way? Andrew?
Sorry. Expressions. But since, like what Jeremiah said, since they're the opposite, we're adding and they can both become positive.
So if above this we had written out 4 minus the -2, what would happen to the minus a negative? It becomes plus a positive, which is why 4 is what I'm looking for. But also, if I started -2 and then minus the 4, 3 would also work. And then these are right out. Any other questions from distance on the number line? Anything from this lesson? This is why we chose to do this on a Friday. Your your homework has been posted since yesterday, I think maybe a couple days. So we only have like 10 minutes left. This is when especially, and I like that Accelerate 7 is on Fridays this year, you can, if you really want, you may get a Chromebook to work on work, or we're going to play Mind Trap, which is one of my favorite games.